I have a couple of questions about string theory and entanglement. And this might be kind of a naive question, but I'm sure our listeners who don't know the answer to this will also be curious. But what I'm hearing then is that string theory is also totally subject to the entanglement that we're familiar with from quantum mechanics. String theory isn't in any way a path to get away from spooky action at a distance.
No, that was certainly not part of it because string theory started from a quantum mechanical theory. Actually, I said there was this assumption about particles made up of strings. And the beautiful thing in string theory is that then we can also kind of derive gravity because gravity becomes associated to the excitations of one of those strings. But the important thing with string theory is that it never replaced quantum mechanics by anything else. So string theory accepts quantum mechanics as totally correct, and everything that we know about quantum mechanics, like entanglement and so on, is also part of string theory.
Right. No, that makes total sense because if I'm recalling correctly, string theory, though it, of course, iterated many times, it emerged from trying to model the string force, or I mean, the strong force as string. So it emerged from within the standard particle model. But this raises, though, another question. I mean, within quantum mechanics, there are many different interpretations that seek to make sense in various ways of such unintuitive features of quantum mechanics as entanglement. And I'm wondering, because I've never heard about this before, if these interpretations, so I mean, Bohmian mechanics, many worlds, and so on, if they carry over to string theory, like is there a vibrant foundations of string theory community, or does string theory have its own canonical way of explaining why strings are entangled?
So the interpretation of quantum mechanics, actually all of them have to do with how we can reconcile quantum mechanics with our classical experience in our classical world. And so we have normally some way of translating the quantum description into our classical experience, which has to do with measurements and the probability of a certain outcome. So this whole discussion about the interpretation of quantum mechanics has to do more with the interpretation of our classical world. So string theorists, to be honest, they think the world is quantum mechanical. And so the world, we don't have this, we don't think that this interpretation issue actually plays a role in how we do quantum mechanics. It's kind of what Feynman said. I mean, with quantum mechanics, we know how to calculate and we calculate and don't ask questions. And that's kind of how we also deal with it within string theory. So the interpretation issue is not something that we think about. Although one thing that I have to say where it becomes kind of important is that when we try to apply quantum mechanics, say, to the entire universe, I mean, then you have to start thinking about what it means to have these probabilities and so on. And maybe this is where string theorists eventually have to enter into this more interpretation question. But certainly it has not played an important role in our research so far. And I don't think also that string theory has a lot to say actually at this point, which of those different interpretations might be correct. I mean, the role of entanglement, by the way, is important. And actually, this is also something that has played quite an important role in some of those interpretation aspects. I mean, one way to think about why the world looks classical also is to think about entanglement and things like what we call decoherence and so on. So there's lots of overlap, but not something that has become an important discussion point about this interpretation question.